to a couple things. We're going to have a little bit of a delay. See that wave you guys just did? That just got to him over there. But we're gonna have a little bit of a delay, but he's gonna do this presentation here. We will have time to take questions. We'll just have to type them into him so we don't have that weird pause between question, answer, delay. Jolie, is there anything else you want to add before we get started?
Nope, I think that's good. I think we're ready to get started. Right. So I'm going to introduce our speaker today. This is Mr. Les Murray. He is a volunteer with NASA, and he has been trained by NASA to be a solar system ambassador for the space program. So without further delay, let's all give him a round of applause.
Hey guys, so as she said, my name is Les Murray, and I am a solar system ambassador. And what a solar system ambassador is more NASA volunteers. We're trained by NASA. About every week or two, we have a presentation with NASA, and they let us know what's going on there at NASA. I've never worked for NASA. I'm just, a volunteer, somebody who loves science, and they have taught us how to, go out and share what's going on with NASA with all of you guys. I wish that I could have been there today, but unfortunately I caught a respiratory illness, and I did not want to spread it around. So I'm doing this remotely, but hopefully you guys will still enjoy finding out about Psyche, the most metal of asteroids. And I'm going to share my screen now. All right, so you should be able to see it now. And this was a talk that was given to us by the chief scientist on the Psyche program, Lindy Elkins-Tanton, who's from Arizona State University. And a lot of the stuff was put together by the actual Psyche team. But what we're going to talk about today is Psyche. It's an asteroid, and Psyche was formed early on in the solar system's history. The solar system, came together about 4.5 billion years ago. And in fact, when we look out with telescopes today, we can actually see solar systems in the process of formation. And early on in the solar system, a lot of the material is what's called undifferentiated. So if you look at this guy, it just looks like, a real mess, right? Together, you've got all different kinds of pieces of both stone and metal and various things conglomerated together. In fact, it looks very much like a stone that you might find out along the side of a river. It looks like sedimentary stuff. And this is what's known as a chondritic meteorite. And as I said, it's what's called undifferentiated because it has not, been separated into its various parts. But many of the larger bodies in the solar system, if they become large enough, get to be differentiated. And what that means is they might have an iron core like this. Our own Earth has an iron core surrounded by, magma, and then a crust. And something that's a little bit different than Earth is when you have an asteroid, the outer material is usually rubble that has, accumulated on the surface later in the life of the asteroid. So this only happens to the bigger asteroids. And you might ask, well, how in the heck do you get a molten core and magma in an asteroid? Well, if they get big enough, And early in the solar system's history, they actually had radioactive aluminum in it. So there's a radioactive element, aluminum-26, which is very radioactive. And a lot of it was produced right when the star kicked off. So when the sun just was born, a lot of aluminum-26 was created, which is short-lived but radioactive. And that actually helped melt a lot of these asteroids and actually differentiate them. So once they melt, right, the heavy stuff will go to the center, followed by the lighter and lighter materials in layers, kind of like a layer cake. So here you can see kind of some of the different histories that can happen in the solar system when things are forming. So you can see over here, you know, very small, loosely held together bodies. And as time goes on, they'll accrete more and more and more matter and get larger and larger. And if you're up on this branch, you're the lucky ones. And you keep accumulating matter and eventually become a planetary body. So this is this is the lucky path. But you know, and one of the things that happened early in Earth's history is it was hit by another Mars-sized body, which melted the whole outer crust, and in fact the whole planet, generated the moon, and gave us a very you know, strongly differentiated body with all those same things: the crust, the magma, the mantle, the core. Now, back here, if we go back here, there's another path, which is not so lucky for other asteroids and bodies. And that's where early in the solar system, it was kind of like a you know, crash up derby, where there were lots and lots of collisions. And with Psyche, it was a very special collision. So it was actually struck by another body, but it was a glancing blow. So it actually hit off center and had a lot of velocity, and it actually stripped off all the outer layers. And that probably took 4 to 8 collisions, which is very, very unlikely. When they do simulations, that's a very, very unlikely outcome. But we were lucky enough to have one. And it's really very, very cool, and something that we can learn a lot from, because with the Earth, you could never, ever get to the core. Like, it's unlikely that we'll ever learn anything directly from the Earth's core, because the Earth's core is so deep and there's so much magma and other things between us and the core. It's unlikely we'll ever sample the core, right? But the cool thing about Psyche is the solar system already did the work for us and stripped out off all the outer layers. And so now all you've got is the metal heart of an early planetoid. So Psyche really is, you know, the most metal of asteroids. In fact, it's very metallic. And you can see right here kind of an artist's rendering of what that collision might have looked like. And you can see that it kind of hit off center, and how it might strip off all those outer layers. So all that outer rocky material is totally stripped off, leaving that hard metal core. So if you know anything about the Earth, Earth has a magnetic field. And the reason why it has a magnetic field is its core in the center is molten metal, and that molten metal is spinning. And when you have charged material spinning, it creates a magnetic field. Well, one of the things that we want to be able to look at is that magnetic field, because this asteroid is very small, and so it will actually end up, it's completely frozen solid, so the metal is no longer molten. And what's really cool about that is if it was magnetic at the time, when it cools, often that magnetic field will be frozen into the metal, and you'll actually still be able to detect the magnetic field. So if we can go and see that it has a magnetic field, we know that at one point it definitely was molten, it definitely was spinning, and likely it was at the center of a planetesimal. But then also you can see some of this material that was probably left over from one of the collisions that will eventually probably land down on the on Psyche itself. What's also kind of interesting is, like Mercury, once the metal has cooled, as it cools, it contracts. So what that'll do, you see this sometimes in ice, is it will form little cracks and fissures. And it's very likely that there is sulfur inside the asteroid. And if you actually squeeze it, it's very likely that at some point there were sulfur volcanoes on the surface. So we'll also be looking for both that magnetic field and also for the sulfur out on the surface. And here's another artist's rendering of what that glancing blow might have looked like. And it was clearly a very energetic collision. So to strip off all of the outer layers, it had to be a very energetic collision. So, and this is what it might have looked like shortly after the collision. And collisions this violent, the kinetic energy is how fast is it moving and how much does it weigh? And those two things put together represent a lot of energy. So when they strike each other, a lot of energy is imparted. And so immediately the surfaces would be molten because all that energy has to go somewhere, and it goes into heat. And also, you know, would have likely melted most of the outer part of the asteroid. So 16 Psyche, why is it called 16 Psyche? It's because it was actually discovered back in the 18th century, and it was the 16th asteroid found. I believe it was found by the University of Naples, the observatory in Naples in the 1800s. And it was, it's an M-type asteroid, or a metal asteroid. There are chondritic, the one like we saw at the very beginning, and there's M, which are metal type asteroids, and it's actually quite large. So it's 240 kilometers. I don't know if you can imagine, but that is pretty darn big. And we're pretty sure that it's almost all metal. So its density is very high, which speaks to being a metal. When we look at its spectra, or all the different colors of light that are reflected off of it, our best guess is that it's 10% silicate or rocky matter and 90% metal. So 90% of a 240 kilometer planet or planetoid is all metal. It also, when the Arecibo telescope was still going, that's a radio telescope, and it would actually use radar to look at the 16 Psyche. It had high albedo. That means it was very reflective and had a high dielectric constant. So all those things tell you it's almost definitely metal. And it also, the way that it heated and cooled also gave you a good feeling that it's definitely metal. And the lucky thing about it is, because as far as we know, there's only one similar, only one asteroid like this large and metallic. But luckily, it's easily reachable for us. It's only about 3 AU out. That means 3 times as far out as the Earth. So it has to travel out from the sun 3 times the Earth distance. And it's in a relatively circular orbit. And the inclination's not too much. So it's not tilted much relative to our the way the Earth is. So therefore, it's a pretty relatively easy thing to get to. So here's some of the comparisons. Vesta is the largest asteroid out there, and it's about 265 kilometers. And you can see Psyche, it's about 105 kilometers. And these are the best shape models that we have. And then there's Eros. That's one of the asteroids we have already visited. It's 16 kilometers. So it's like 2 tens, hundreds, thousands, 10,000ths, 2 10,000ths of the size of Psyche. And then we just visited Bennu, and you can see, relatively speaking, Bennu is just a little pinprick, relative to the rest of these bodies. So since the research for all this was done at Arizona State University, their comparison was Psyche's about the distance between Flagstaff and Phoenix. So if you can imagine, if you plop down that asteroid, right there on the Earth, it would be almost the full distance between Flagstaff and Phoenix, or about the same width as the state of Massachusetts, and has about the same surface area as the state of Texas. So it's an incredibly large asteroid. So what do we want to figure out about Psyche? Well, our best guess is that it's a core that's had its outer layer stripped off. But in science, unless you have the data, it's just a guess. And it may be an educated guess, but at the moment, until we get some data, it's a guess. So it could also be unmelted, undifferentiated, but that's unlikely given all the things I've told you. We want to try to figure out how old the asteroid is. And, with people, you look at their faces and you count the wrinkles. And that's kind of how you determine, about how old somebody is. And we do something similar with asteroids or any body. And we count the craters, because the longer it's been around, the more craters it will have. We want to know what it's made out of. How much of metals and how much of silica or rocks. We want to figure out whether it was formed the way we suspect, or is it possible it was formed right next to the sun in a more oxidizing environment, and effectively the sun smelted down iron into this body. So that's not the leading theory, but that's one other possible theory. And we also want to get a look at it, like what the heck does it actually look like? And the reason why is today our best imaging of Psyche is the Hubble Space Telescope. And on the Hubble Space Telescope, this occupies exactly 2 pixels. In backyard telescopes, it is exactly 1 pixel. So clearly, you know, we couldn't tell a whole lot about it from its visual observations. And we have been able to get fairly good images of it using the Arecibo radar, but you know, we've never actually seen it. Don't have any pictures of it. And so we want to know, you know, is it a core? Did it cool from the outside in or the inside out? Is it actually really just like many of the asteroids we've seen, just a rubble pile, a junk pile? Or is it like we saw in the very beginning? Is it undifferentiated? Is it just a kind of a mix up or a sedimentary type aggregation of all the materials? Now, clearly, once again, from everything I've told you, the most likely is, you know, differentiated and more like over to the left, but, you know, we really don't know yet. But also, if it cooled from the inside out, then there should be high nickel on the surface. And if it cooled from the outside in other words, the outside cool first and then cooled inside, then we should have low nickel. That's one of the things we can actually measure. So we'll talk about what kind of neat instruments does it have. And this is just a graph showing that basically the faster it cools, the more nickel content on the surface. So the other thing that we want to do is we want to characterize the topography, or what does it look like. From Arecibo, we know that there's at least one big crater on the surface. Likely there are others, but we know there's at least one big crater on the surface. And we want to get our imagers and actually take pictures of the asteroid and see what it looks like. This is actually a picture taken by the principal scientist in her backyard. And as you can see, there's not that much detail, right? It's just a single pixel, not much to it. So we have wondered a little bit about what would craters look like on this on the surface of Psyche. And this is actually a experiment that was done that fired a high-speed projectile out of a large gun that they have there at NASA into a block of metal to understand what does cratering look like in a block of metal. And as you can see, it actually did dig a quite deep, smooth-walled crater. It has a big overlip or overhang that you know, is around the crater. And additionally, you can actually see these voids which were created underneath the main crater. So that's our best guess at what a crater might look like on a metal asteroid. And there might also be a lot of palisite on the surface, because palisite is created at the core mantle boundary. And so the thought is that, you know, if the outer stuff was stripped off, you might actually have a lot of this on the surface. And it's basically an agglomeration of iron and something called olivine, which has iron and magnesium and silicate in it together, and actually is something that's used for gem-like stones. But there might be actually a lot of that on the surface. So this is a short video showing what it might look like. This is all obviously conjecture because we've not been there yet. But this is the Psyche spacecraft, and it will actually go into orbit, clearly not as low as this artist rendering, but it'll get down to about 100 kilometers. So essentially about one Psyche diameter away, and we'll be able to study the whole external surface of Psyche with all its instruments, which we'll talk about in a little while. Now I have one other presentation which I'm gonna give you. All right, so this this presentation was given by David O, and he's the chief system engineer, which actually happens to be my job in a high-speed data networking company. But so I can kind of relate to his job. But he's gonna tell you a little bit more about the actual probe itself, since he's one of the chief designers for that probe. So this gives you kind of the timeline, and I've actually updated this timeline because it was originally scheduled to launch in August of 2022, but due to some problems that were found close to the launch, it was decided to postpone it for 1 year. Unfortunately, 1 year put it at a less than favorable path to Psyche. It's still I'm sorry, going there. It will launch in October of 2023, but unfortunately it means it'll get there 3 years later out at Psyche. And so to launch from Earth, it'll go out to Mars. It'll do a slingshot maneuver around Mars to gain extra velocity. That'll happen. I don't have a date for that. They didn't give an updated date for when that would happen. And then it should reach Psyche August of 2029. So you can see it's about three years off of the original schedule, because even though relatively speaking it's in pretty close, it's still a good ways away. So now the probe was actually built as a partnership between NASA and JPL. That's actually the NASA lab that sponsors the Solar System Ambassador Program, which I am a part of, and Space Systems Loral, who actually makes mostly geosynchronous satellites. And the reason for that is the construction of the probe. And we'll talk a little bit about what is on the probe. So it has a magnetometer. We said we wanted to be able to see the magnetic field and figure out whether it had once been a melted spinning core. So that's the purpose of that instrument. There's a multispectral imager. So there's an imager that we can take, normal white light pictures, but it has a number of filters. So we can also do some filters that help us understand what the composition of the surface is. And then another very important instrument is the gamma ray and neutron spectrometer. So if you remember what a spectrometer is, what it does is looks at the spectrum of light reflecting off an object, and it looks at what frequencies of light it receives, which tells you what types of materials that make up that body, in this case, Psyche. And it's a very interesting kind of spectrometer because it's a gamma ray and neutron spectrometer. And so what happens is cosmic rays are coming in from space. So they're high energy particles. They strike Psyche and cause gamma rays to be produced. We sense those gamma rays and we are able to use it to figure out what the body is made of. So it'll basically orbit around Psyche for, up to, I think it was 21 months. Yeah, 21 months. And it will build up basically a spectral map of what's on the surface of Psyche. So when it's done, we'll actually know what's there. So when it goes out to Psyche, normally many missions use chemical rockets, and chemical rockets are a good thing, but their thrust level is very high. Their fuel efficiency is pretty good, but they're very short-lived, which means they can't thrust for very long. And there's actually a more efficient propulsion, and that's solar electric propulsion. And in this case, a Hall effect thruster. Well, its thrust is very low. It can push with the weight of about 3/4. So if you took three 25-cent pieces, quarters, and you stacked them up, that's about how much thrust this produces. But it's very, very, very efficient. So it takes power from the solar panels and xenon gas and turns it into a thruster, an ion thruster. And its fuel efficiency is very, very high. It's about 4 to 5 times that of the chemical rocket. So what does that mean? It means less fuel, and much of the energy that you're using is actually coming from the solar panels. And you can get up to 1600 ISP, which is very efficient. And the other thing is it thrusts for a very, very long time. So the electric propulsion, chemical propulsion rarely lasts more than 15, 20 minutes tops. The electric propulsion is going to, thrust for months on end. So this is a picture of that SPT-140 Hall effect thruster, and it uses xenon gas, one of the noble gases. It excites it and then accelerates the atoms of xenon out the back of the thruster. And it kind of looks like something from Star Trek, or you might see from Star Wars. But that's the Hall effect thruster. And that is what Space Systems Loral brings to the table, because these have been used on satellites in Earth orbit for a long, long time, but never for deep space mission. They're very reliable, very efficient, but have never gone to deep space. There are similar ion thrusters, but not this one. So that's what they bring to the table. And then NASA's Jet Propulsion Laboratory there in California, NASA JPL, it actually has done many, many, many missions, and it actually has built many flight computers, and they actually based this particular probe on the Curiosity flight computer that was used for that mission that does have deep space navigation capabilities. So you get deep space navigation from Curiosity, you get a Hall effect thruster from the geosynchronous satellites. You put them together into a probe that can go visit the Psyche asteroid. So it's going to launch from Cape Canaveral. So it'll launch from the Cape Canaveral Space Force Base there in Florida. It'll deploy its solar array shortly after it reaches orbit. It has really huge solar arrays. They're about the size of a tennis court when unfolded. And there's 5 of them on each side. And it'll use that it'll turn on its Hall effect thruster and start climbing out of Earth orbit. And one of the other things it's going to do is it's going to demonstrate deep space optical communications using a laser. So today, with the radios, once you get out really far, like 3 AU, the speed of communication via radio is very, very slow. It's not more than several hundred kilobits, which you have to be pretty old like me to actually remember when things were that slow on the internet. And but this is a demonstration using lasers, which can do multi-megabit communications back to Earth. It won't be used for the mission per se, but we'll do a technology demonstration, and if it's successful, then it might be used on future missions. But clearly, if it's the first time out, you can't depend on it, and so it's just a technology demonstration. They're going to do that Mars gravity assist, and it's going to then do 4 sets of orbits at different altitudes, each with different science goals. Measuring the magnetic field, doing imaging, using the gamma spectrometer to figure out what's on the surface. And this is just a rendering of that. And as I mentioned, it's a little bit of an artist's conception because it's not going to get near that close to the surface. But you can see kind of some of those raised ridges that we were discussing that may have happened due to the cooling. Also, with Arecibo, we know that there's at least one really big crater on the surface, and we're relatively sure that it has a few of these spiky horns that you can see there, which are sticking up above the crater. So, that gives you a little bit of an idea about the Psyche mission. And I don't know if you have any questions that you want to ask. Does anybody have any questions? And they don't have to be about the asteroid. They can be about most subjects. Yeah, if you'll enable the audio so I can hear them. There we go.
I'm gonna go ahead and ask your question.
Yeah, so, where did they make Psyche and how much did it cost? Where did they make it? You'll enable the audio so I can.
So the question we have in the room was, where did they make it and how much did it cost?
I do not know the cost. I know that a lot of the design was at Arizona State University.
Where did they make it and how much did it cost?
Yeah, that lag.
I do not know the cost. I know that a lot of the design was at Arizona.
So there's a question out there. How far is Psyche from Earth? Psyche is 3 AU, or astronomical units, out. So the 3 astronomical units is 3 times the distance to Earth, which is 98 million miles. So let's call it roughly, about 300 million miles out.
There's a question out there. How far is Psyche from Earth? Psyche is 3 AU, or astronomical units, out. So the 3 astronomical units is 3 times the distance to Earth, which is 98 million miles. So let's call it roughly, about 300 million miles out. The question out there, how far is Psyche from Earth? Psyche is 3 AU.
Oh, that's a good question. How hot is the magma? So that's a good question, which I don't have the answer to. In previous things where I have heard about magma typically was in the 1500 degrees Celsius range. But I really can't say. You could probably look up the melting point of iron, which most of the asteroid is made out of iron. The second most abundant thing is nickel. And so if you looked at the melting point of iron, that would give you a really good idea of what the core temperature could have been at some point. Unfortunately, that's not my discipline, so I don't have really good answers for you there, but I can give you what little I know. Any other questions? And you're welcome to ask questions about space, NASA, other missions. All righty, well, last chance. If there's no other questions, then we'll finish up for today. And we'll let that lag on YouTube play out. Oh, okay. I see some more questions. One of them is,
I think that there are a couple more questions in the chat still.
Yeah, I see them now. One of them is, what is nickel? So nickel is one of the elements. It's a metal. And in fact, just like it sounds, when you get a nickel at the store, it literally is made out of nickel. That's the metal nickel. One of the other questions is, will the asteroid ever hit Earth? No, this asteroid is not on any path that would ever hit Earth. I don't know if you remember when I showed the information about it, it was 3 AU out and its orbit was almost circular. So that means that we would never cross the that asteroid. So this is something that's never gonna endanger us. But it is one of the things that many people would actually like to go out to this asteroid and mine it, because clearly the value of all that metal, and there's a lot of precious metals, they're trace, but there's a lot of precious metals like gold, silver, palladium, all those precious metals. And so there's a whole separate industry that would like to mine this particular asteroid. There was a question about how hot was the crust, but that's my best answer at this time. And the question about what metals are expected to be found. Primarily iron, nickel, and a lot of those very valuable rare earth metals. And for the people that were asking about the materials that it's made up, a lot of those are conjectures because as you know, we haven't made it there yet. And until we do, we won't really have a good idea of what's there. All righty, let's see if there's any more. Oh, how many asteroids has NASA found? Oh, how many have they sent probes to? Well, the ones that we've sent probes to that I remember, there was the Dawn spacecraft, which I believe visited 2 asteroids. We've also just recently visited the asteroid Bennu, and actually took a sample, and it's on its way back. We've also visited the just recently with the DART mission. We visited the 2 asteroids, Didymus and Dimorphos, and crashed into one of them. So we, you know, had a rather strained relation and crashed into it. But those are most of the ones that we visited. There's a couple of more missions that I can't remember off the top of my head, but those are some of them. All right, looks like we got a couple more. How hard is magma? Well, unfortunately, I am not a geology person, so unfortunately, I don't have a really good answer for you. Does Psyche have a core? Well, Psyche, as our best understanding, is the core of a planetesimal, right? It's the metal heart or the metal core of a asteroid, and so it's all that's left, right? So it's all that's left of that core. How can the mining be done from a distance? Well, unfortunately, unlike video games, you probably have to actually visit, and it literally would be very interesting because it only being a few hundred miles wide, a few hundred kilometers wide, the gravity is going to be quite low. And if you could imagine, you know, how do you dig into something as hard as metal while trying to stay attached to the actual asteroid? So I think it's going to, a lot of neat, interesting technology is going to need to be figured out. And that's where we could use a lot of really great NASA engineers and scientists to help us figure that out, or somebody in business or industry to figure out how to do that mining. As far as a rover, somebody asked about a rover to research it. I think it's probably unlikely with something that is this low gravity. It's really difficult to actually stay on the body. And so I think it's unlikely that you could have a rover. Maybe, you know, because it's a metal asteroid, that might be something that is useful. I don't know, maybe you could use a magnet. But in general, it's really difficult to have a rover. Most of the sampling missions have just dipped down to the asteroid, grabbed a handful of material and then left. They haven't really spent much time. And in fact, one of the ones that did visit actually bounced quite a bit, right off the asteroid when they tried to land on it. So how often do asteroids hit the Earth? Well, actually, every night, fortunately, mostly small ones. There's actually, on the internet, which you can look at, there's actually NASA cameras that are all sky cameras that stare up looking for just that. Fortunately, it's very rare that we actually get very big ones. And thankfully, the last one that hit that was of any size was the one that hit the dinosaurs. There was one in the Tunguska, which was in the early this century, or last century, I guess. I think it was 1902, if I remember correctly, that knocked down several hundred kilometers in the Russian forest. So, you know, call that 100 years. And then, what was it? Within the last 10 years or so, they had that other one over Chelyabinsk that hit and broke out the windows in a lot of buildings. So they actually hit quite often. Fortunately, big ones don't hit very often, but that's exactly why we definitely want to know where they are, and we want to know when they're headed for Earth so we can stop them. So one of the questions is, how are we going to swing around Mars? And so that's what's called a gravity assist. So what it does is it goes close to Mars in the direction that Mars is spinning. So it goes in the same direction that Mars is spinning. And so what happens is you gain a little bit of the speed of the rotation of the planet. You actually steal it, and then it actually speeds up the spacecraft. And most spacecraft going to the outer solar system typically do either a Venus or a Mars or a Jupiter gravity assist to get a lot more speed, because it's free velocity, right? Every mile an hour that you can get gets you there faster. So you know, you can see with just missing it by a year, you know, can cost you a lot of time, and you know, all the way out to 2029 before the Psyche mission will actually reach that asteroid. Any other questions? A lot of good questions. I wish I could answer more of them. So. Right. Well, that looks like about the last question. I don't know if anybody else has one. Also, I'm going to do one quick thing. I'm going to show you. Somebody had asked, how often do things hit the Earth? Well, this slide shows you exactly how often. If they were about 4 meters, it's about 1 time per year. 25 meters about every 100 years. This is, you know, kind of like the one that hit over Russia. About 160 meters about every 25,000 years. 1,000 meters every 500,000, or 10,000 meters about 1 to 200 million years. So we're actually, there we go. Sorry, I just realized I didn't push the last button to share. So, you know, hopefully you can see that, but that gives you an idea of how often those guys hit and how many of them we know about. We know of all the big ones, 90% of the 1,000 meters, 42% of these guys. Unfortunately, the little ones we don't know, and there's probably about 500 million, somewhere in that neighborhood. Somebody asked, what was the first rock that NASA studied from Mars? So one of the things that allows us to study other planets is sometimes planets get struck so hard, like Mars and like Earth, that it kicks material up into space. And we actually have several meteorites that we know came from Mars. They have the same composition. Their composition isn't like Earth, and it isn't like the asteroids, and it is like Mars. And so we're pretty darn sure that they came from Mars originally. And that's actually how we have studied them. and know a little bit about Mars. Now, obviously, we had rovers there for a while who told us all about the geography and all about, you know, what types of rocks and things are there. And so, you know, that's how we know about it. So the question is, what is the point of learning about asteroids? Well, number one, we'd like to know what they're made out of. For those of you that attended my last one about the DART mission, that was all about protection of Earth. And so if we know what they're made out of, we can know better how to stop them. Because like with the DART mission, it was a rubble pile. With Psyche, it's a solid metal asteroid. And some of them are more like chondritic meteorites, like we saw before at the beginning of that presentation. So knowing what they are made out of would be very helpful. Secondarily, something like Psyche could actually start a whole industry in space, right? Because it's actually cheaper to take material from Psyche and build with it and put it into orbit of, say, Mars or Earth than it actually is to lift it off of Earth, because our gravity well is so deep. So it's actually a much better prospect to actually mine asteroids for materials to build habitats in space. All righty. Lots of good questions. I appreciate every one of them. All right. Well, I think that is it. So if so, then we will, you know, thank you guys for attending, and appreciate all the questions. And you know, if I missed any of your questions, sorry about that. Hopefully we got them all. All right. Thanks a lot. I think that is it. So if so, then we will, you know, thank you guys for attending, and appreciate all the questions.
Les, I think we had two
okay.
other questions in the room.
Okay. All right. Thanks a lot. What were the other two?
That big delay. Sorry. Les, I think we had two other questions in the room.
Okay.
So the first question we had was about
what were the other two?
About UFOs and
okay.
how NASA recently had a big push asking the public for input about UFOs, and has that increased the interest in UFOs?
Yes, so what we can say is that there has been a relatively big increase in unexplained sightings. I actually forget the new term for them, but it's no longer UFOs, but there has been a renewed interest in that, because there have been a lot of interesting sightings that we can't explain. One of the theories has been that a lot of this is actually unmanned vehicles that we're seeing, but that, you know, me personally, I have not studied that and don't really have any special knowledge on that subject. But there has been a renewed interest in that, because there have, you know, but I know that there has been a call for them to give you their video and allow them to study it. Is actually unmanned vehicles that we're seeing, but that, you know, me personally, I have not studied that and don't really have any special knowledge on that subject. But I know that there has been a call for them to give you their video and allow them to study it. It's actually unmanned, but that, you know, me personally, I have not studied that.
Okay, and I think that you've answered all the rest of the questions in the room. Sorry about the audio problems that we've had, and we really appreciate you being here, and thank you so much. I'm gonna let everybody give you a round of applause.
Thank you. I appreciate all y'all coming.
You've answered all the rest of the questions in the room. Thank you so much.